2012 Physics B for response. And now we're going to look at forces on an incline. So this says, so we have a little guy pushing a block up a hill. And it says a box is being pushed at a constant speed up an inclined plane at a vertical height of 3 meters above the ground, as shown in the figure above. The person exerts a force parallel to the plane. The mass M of the box is 50 kilograms, and the coefficient of friction between the box and the plane is 0.3. And part A says, on the dot below that represents the box, draw and label the forces, not the components acting on the box. So again, this is similar to what we did before, just a little trickier because you're on an incline. So you have to remember your normal force is always perpendicular to your plane, and then your applied force is obviously going to be parallel to the plane, and then your friction force will be working in the opposite direction as your applied force. But then the tricky part is gravity is always perpendicular to the ground, so it's not perpendicular to the plane at this point. So we just have to remember that gravity is actually in 2 components, but as I said, don't draw it on here. So then part B asks, calculate the normal force of the plane on the box. If you need to draw anything, use the space below. Basically, don't draw your components up here. So I moved to some extra paper for part B, and we look up here. So we say this, so I kind of redrew it up here just with the components because personally I like visualizing it. So our sum of forces in the y direction is our normal force minus our force of gravity, the y component. And so we can say they're equal to each other because the problem said it's at a constant speed. So we know that our acceleration is 0 because our velocity is constant. So we end up setting those equal to each other. So our normal force is equal to the mass times gravity times cosine of 20 degrees. And we plug in all of our numbers. Our mass is 50 kilograms, and we solve for our normal force is equal to 460.9 newtons. Now, part C says, calculate the component force of gravity acting on the box that is parallel to the plane. So again, this diagram over here helps me. Our x component is what's parallel to the plane. So this is basically just solving for the opposite component that we solved for earlier. So the FG, that's a little parallel sign. So the parallel force, or is basically the F, is the gravity x component force. So we can say the force of the x component of gravity is equal to mg sine 20 degrees. And you just have to look at the angle and figure out if your side is opposite or adjacent to figure out if you use sine or cosine. And then we can say Fg of x equals 167.76 newtons. Now, part D asks to calculate the friction force between the plane and the box. So we say the F of friction is equal to the coefficient times the normal force, and we just calculated the normal force right here. So we plug that in. They told us our coefficient was 0.3. We plug it into our calculator, and we get 138.27 newtons. Now part E is where it'll get a little trickier, and part E says calculate the force applied by the person on the box. So we again set up our sum of forces in the x direction, and then we have our force applied, because our force applied by the person, minus the F of g of x. Remember, it's not just gravity. We have to look at this component of gravity because that's working the opposite direction as our applied force, and then subtract our frictional force. So we set all those equal to mass times acceleration. Again, velocity is constant, so our acceleration is 0. So we can say that force, the applied force, is equal to the x component of the gravitational force plus the frictional force. And we solved for the x component of the gravity force and the frictional force right here. So we just add these two numbers and plug it all in right here, and we'll get our applied force is equal to 306.037 newtons. Part F is probably the hardest part of this problem. It says calculate the work done by the person pushing the box, assuming the box is raised to the vertical height of 3 meters. So I don't think it's by this unit we had done work yet, but I don't really remember. But anyways, we've covered it now. So work is equal to the parallel force times distance. So we have to use our sine rules and say that sine of 20 degrees is equal to opposite over hypotenuse, so 3 meters over our distance. Solve for distance, and we get 8.77 meters. And then we can say work equals force, our applied force times distance, and our applied force we'd solve for right over here. Plug that in, plug in our distance, and our work is 2,684.37 joules. So I have gone over how to figure out tension forces, force on incline, and lab free response questions. Hope this helped.